A comparative study of machinability of aluminium and its composite with boron carbide by varying grain size. Aluminum metal composite are the most encouraging material which gives most noteworthy mechanical quality in the field of hard machined material. Inferable from its higher strength to weight proportion, it is widely applied in the aeronautical assembling and aviation industries. Throughout the long term, researchers continuously practices to reduce the cost of machining process, and numerous analysts have indicated unmistakable fascination for expanding further developed machining measure. During machining of aluminum compound materials, the proper machining and cooling circumstances assume a basic part as it influences the machinability. In this study, 3 samples are taken: pure aluminium particle size 50 micron, approximate, aluminium with 10% reinforcement of boron carbide with 50 nanometer, approximate. The effect of varying cutting speed and feed rate was analyzed on factors like feed force, cutting force, surface roughness, and tool wear, crater and flank wear. It was observed that at low feed rate and at high speed the machining of material was preferable. Keywords: boron carbide, matrix, MMCs, reinforcement, AMMCs. 1. Introduction. Aluminium silicon compounds are most appropriate for assembling automobiles parts as it decreased weight, which is getting more significant both in natural and business needs. They have great corrosion resistance and reusing capacity, which is a lot wanted when machining is required. Machining is pondered as one of the most basic assembling cycle to deliver parts with wanted shape and dimensional exactness. Choice of reasonable machining boundaries causes the industrialists to have command over different autonomous factors associated with machining. Numerous investigates are completed in machining measures considering cutting conditions, cutting apparatus materials, surface roughness, apparatus wear, device life, power utilization, and so on. 1. The significant advancements in science and designing is the improvement of composite materials. Composites comprise of metals and their amalgams known as metal matrix composite. In Al metal matrix composite, AMMCs, one constituent is aluminium combination, which go about as permeating system and is known as network stage. The other constituent is implanted in this grid stage and fill in as fortification. The support is normally non-metallic and are generally ceramics like SiC and Al2O3 by fluctuating the nature and volume portion of the constituents properties. Aluminium metal matrix composites, MMC, can be custom made. Exploration with respect to machining of metal network composite was initially started in 1980s, and the majority of work depended on aluminium metal matrix composites aims on machinability, uniquely tool life, and the streamlining of cutting apparatus performance too. Powder metallurgy handling is a powerful strategy to fabricate MMCs with high, medium, and low volume of fortification with genuinely uniform circulation. Powder metallurgy pass on to create pitifully strong, cold welding, close to the components of the item at last to be produced. Weights of 1 to 15 tons are commonly used to minimal the metal powder and structure green part. At that point resulting warming or sintering is done of green part in the form with temperature underneath melting point under non-oxidizing environment. 3. Est Hannah Lakshmi, T. Ramesh Babu. 2020, 4. This article examine about the enhancement of machining boundaries in turning LM25 aluminum amalgam in wet and dry conditions. The boundaries considered for machining are cutting rate, feed, and profundity of cut, with the exhibition measures as surface unpleasantness, material evacuation rate, and cylindricity mistake. Taguchi's L9 symmetrical exhibit was utilized for directing the examinations. The boundaries are enhanced at the same time by Gray relational analysis, GRA, strategy. The effect of the machining boundaries on execution measures were thought about on both wet and dry machining situations. M.C. Santos, A.R. Machado, M.A.S. Burzo, M.J. Jackson, E.O. Ezugwu, 2014, 5 parameters such as instrument wear, apparatus life, cutting temperature, machining power segments, power utilization, surface trustworthiness, and chip thickness proportion are routinely utilized. The point of this work is to examine the conduct of the machining power, FU, chip thickness proportion, CTR, and chip removal when turning flexible, 1350O grade, and of high quality, 7075 T6 grade, aluminum composites at different cutting conditions, cutting rate, VC, feed rate, F, what's more, profundity of cut, Doc. A central composite design, CCD, of tests was utilized that created second request models of the boundaries, FU, VC, Doc, F, CTR, VC, Doc, F. Surface reaction strategies and level bends were utilized for examining the impacts of the cutting conditions on the yield boundaries, FU also, CTR. The cutting conditions, VC, Doc, and F, that all the while limit the machining power, FU, and the CTR were resolved with the assistance of the hereditary calculation strategy, GAM. K.K. Saravanan, S. Mahendran, 2020, 6 aluminum 6082 compound is blended in with boron carbide fortified material by mechanical stirring. The example is tried by hardness and tensile test. The SEM investigations is done and compute the grain molecule conveyance. These projecting is machined in CNC machines. The machining boundaries speed, feed, profundity of cut and all sort of additions are considered. These machinability contemplates are contrasted in mono compound and composite materials. The machinability esteems are higher for composite material than solid combination. The oddity of this task is to examine the mechanical properties of aluminum 6082 with different weight rate of B4C materials. Ashutosh Kumar Singh, Deepak Singhal, Ramanujay Kumar, 2019, 7 work manages the machining of aluminum 7075 with metal, brass, anode utilizing electrical discharge machining process. The impact of EDM measure boundaries on the different yield of workpiece were measurably analyzed with arrangement of runs. L27 set of investigations are performed with 4 information sources: pulse on time, voltage gap, peak current and flushing pressure, and their 3 levels. By setting the necessary boundaries, material removal rate, MRR, is assessed. And this paper deals with a comparative study of machinability of pure aluminium and aluminium metal composites at different grain size. The factors that going to be studied for machinability are cutting force, feed force, and surface roughness in term of workpiece and crater and flank wear in terms of tool. All these factors are studied under different feed rate and cutting speed. 2. Material and method. The materials utilized in the test is boron carbide with immaculateness 99.95%, density 2.52 g/cm3 and particle size 50 micron and 50 nanometer taken from Parshwamini Metals, Mumbai. Aluminum powder with immaculateness 99.85%, density 2.7 g/cm3 and particle size of 50 micron and 50 nanometer taken from Parshwamini Metals, Mumbai. 3 samples are prepared. One is from pure aluminium powder of particle size 50 micron. The second sample was aluminium metal matrix composite having boron carbide as a reinforcement with weight and also the particle size of both are 50 micron. Third sample was prepared was also a al metal matrix composite with boron carbide as reinforcement, but in this sample the particle size was 50 nm for both aluminium and boron carbide. For making aluminum metal network composite, at first the powder is blended in with one another in weight rate as aluminum 90% and boron carbide 10% by weight for both second and third composite samples. Subsequent to gauging, these samples are blended in stirrer for 5 hours to get homogeneous structure. And after that this blended powder are squeezed through a pneumatic press at a weight of 10 tons for 30 second and shaped green part. These green part are then sent to vacuum heater for sintering, where the example are heated for 60 minutes to form the composite. As hardness of aluminium and boron carbide composites is always greater than pure aluminium 813. For machining, cutting apparatus embed that has a piece of hard, low cover content, unalloyed WCCO fine grain grade, which has uses of brilliant edge where opposition joined with high quality is utilized in the turning of aluminum and aluminium metal composites with boron carbide. A lathe machine which has a speed scope of 60 to 3000 RPM was utilized for turning activities. Tool wear. The crater wear on the instrument face and flank wear on the flank of the tool were estimated under an advanced digital microscope and the varieties were investigated. It has been observed that crater wear is always higher than flank wear. When at constant cutting speed there was an increment in feed rate, both flank and crater wear were discovered to be expanding. This is on the grounds that, with the expansion in feed, the instrument needs to eliminate an expanded volume of material in a similar stroke which enhances the tool as well as chipping temperature, bringing about expanded tool wear. This is shown in Figure 11, Figure 12, Figure 16, and Figure 17. Among all the 3 samples, aluminium, and boron carbide of both particle sizes in micron and aluminium and boron carbide of both particle sizes in nanometer. The third sample of aluminium and boron carbide of particle size in nanometer show less tool wear due to small grain size.